Welcome everyone to our lead up to the Mass Timber Conference. My name is Braxton Allred. I'm a product manager here at Global IFS. And I'm here joined by our Mass Timber expert, Chris Irvin, and our UFAD expert, Jack Gertner, to talk a little bit about what makes UFAD systems so efficient and why we think they're such a good fit with Mass Timber. So I'll let Chris take the reins from here.
Thanks, and welcome to this year's International Mass Timber Conference. Unfortunately, virtual. It would have been nice to get together in person, but next year, I suppose. With us is Jack Gertner. He is our Director of Underfloor Technology and a 20-year veteran of the world of underfloor technologies, whether it be UFAD systems, in the first generation or today's new UFAD designs. And Jack is going to help us understand why underfloor HVAC systems are so energy efficient. So Jack, kick it off.
Well, thank you, Chris, and thank you, Braxton, and easy on that veteran. I'm grizzled, but maybe a veteran. But thank you, and thank you all for attending here at the Mass Timber Conference. We're excited to be here, and a little bit of a different approach for all of us, but I think we'll certainly make it work. As Chris said, we're here to talk a little bit about why the energy efficiency story applies to underfloor, and I'll try to work us through it real quickly. But I thought we just need a level set understanding of how these systems work at the very base. And let's look at an overhead system. Again, this is nothing new at all. It's been around for many years, and the whole idea with an overhead system is to condition the space by introducing air into the space at about 55 degrees. That's typical from a mechanical unit that could be any place in the building. So it comes into the space, like you see here, through a ducted diffuser. It's going to mix the air. The good, the bad, and the ugly, as we call it. Everything that's in that space gets mixed. That's what it's designed to do. And you end up with a temperature in the room that's the same at the ceiling as at the floor, typically about 75 degrees. But as you can see here, it's coming into the space through a network of ducts that run around the building in a nonlinear way. So it takes more energy, more fan horsepower, as we put it, to deliver that air into that space through an enclosed duct. And that's a mixed system. The underfloor system, different paradigm, where we're looking to stratify, meaning we want to have two basic temperature air zones, if you will, in the space. So we're going to deliver that air through the same mechanical systems, but rather than through a network of ducts in the ceiling, it's going to deliver the air directly down, as you see there in the chase, into an underfloor plenum, or an underfloor space under that raised floor, which is essentially a non-ducted space. We eliminate almost all the ducts, and we're delivering the air through pressure-dependent diffusers like you see here, but the air is warmer. Big difference here is that the air is warmer because we don't want to deliver 55-degree air at the space or into the space at people's feet. It would be uncomfortable. So typically we're going to deliver that air slightly warmer, about 62 or so at the carpet. It gains heat as it gets into the space pretty quickly. Big difference as well is pressure. That ducted system we saw on the prior slide takes about 1 inch to 2 inches, depending on the building configuration, of static pressure, meaning the energy to push that air into through that enclosed duct system. Here we're at a fraction of that. These underfloor systems are typically designed to operate efficiently at 0.05 inches. I'll repeat it, 0.05 versus a full inch to 2 inches. So big difference there with just the energy and the fan horsepower to drive that system. Two very different approaches. And just some visuals in terms of what an overhead system can look like. Can be pretty busy up there. Again, lots of different directions, moving the air through the building, and not the least to say is the aesthetics are certainly a big part of it, as you see here in the right slide. So with an underfloor system, we can really remove all that noise in the ceiling, if you will, and put it down under the floor, eliminate a big part of the ducting that's required to to service that space. And here's another good visual of what it looks like with an underfloor system, where, again, as I mentioned earlier, we're either eliminating or vastly reducing the amount of support ducting that's needed to supply the space. And whatever we do need, we can put under that floor and leave a nice clean ceiling. Particularly plays well with mass timber. We're really trying to highlight that beautiful wood finish in the interiors. So, pressure. We've talked about pressure. What else is there? The other big part of the energy story is this one, the Economizer Hours. And this may not be intuitive, but when you think about it, when we go back to the comments about warmer air, if I'm delivering warmer air into the space, I can run my economizers, which basically allow outside air, complete outside air, into the space to condition it rather than mechanically cooling that air. And in this particular graph, you're looking at what it looks like in San Francisco, which is pretty much the poster child for this story because of their climate. In San Francisco, you can make a case for well over 2,000 extra hours of free cooling, and that just translates into money. The more you have to mechanically cool air, the more it costs. So it's a big part of this story when you can run those economizers. And not everybody's fortunate enough to live in San Francisco, and in other areas of the country. However, we still can do it. Not to the degree of California or San Francisco, but certainly there are available hours when we can run those economizers even in places like Minneapolis and Houston, Texas. So that is a big component of the whole energy story. Show me the money. Well, here's some real world data on some buildings in Sacramento. This was a study that was published by University of California at Berkeley, and the bar graphs you're looking at are different buildings in the Sacramento market, and the one on the far left, block 225, is a UFAD design. The rest are the overhead systems we've just looked at. And each building is different. There's lots of variations as to why one is more efficient than another, but clearly the UFAD piece is a big contributor to making it very energy efficient. So in summary, as we look at it, just previewing the last few slides, if you look at your HVAC energy bill, these tactics and these strategies can reduce that 20 to 30% that we've seen across the country over time. And again, the two major components are the reduced fan horsepower, operating at 0.05 in a relatively non-ducted world, versus the 1.5 to 2 inches for an overhead system. And then the free cooling / economizer operation, increased economizer operation. When we are delivering that warmer air, it allows us to use more hours during the year that we can take advantage of outside air without mechanically cooling it. Then the last point is that across these systems, these functional underfloor systems, if we introduce the VAV functionality, where we're using variable air volume, in other words, thermostatically controlled diffusers, we can even layer in more energy efficiency because we can control the space as loads switch in the space. And this little animation, this is building 225 we just looked at. And these were measured by University of California again over time, and shows how temperatures can swing in a building and even on the underfloor plenum. And using the VAV tactic, we can add in some additional energy savings. So all in all, it really adds up to a pretty compelling way to save energy in buildings through underfloor air. So Chris and Braxton, that's pretty much it from a 30,000-foot view level.
Thanks, Jack. I appreciate it. Chris, really quick, you're muted, so if you want to say anything. But no, Jack, that was a great run through. I do have a couple of questions. I don't know, Chris, do you have anything you want to ask Jack too?
I was just going to ask that in today's world with The increased economizer operation, is that going to provide a benefit, that additional outside air, um, creating a higher level of indoor air quality in the breathing zone? And if that's an additional benefit on top of the energy story.
It is, and the ASHRAE, that is the first thing that they'll tell you is to increase your outside air. Makes all kinds of sense in terms of what they call their ventilation rate procedure, which basically is a way to quantify the cleaner air story in a building. The more thinking is, the more you can flush outside air through the building, the better. Now, that, for the most part, it applies really well, especially in places like where you are, Chris, and you are, Braxton, in Denver. But if you're sitting next to the 405 freeway in California, that may not be such a great strategy. So the other strategies that come into play, which are not necessarily limited but to underfloor, but really complement underfloor, is to use some kind of a mechanical cleaning mechanism, which is also recognized by ASHRAE. If you can do that and get rid of contaminants, you can make a case for less outside air in places where maybe you don't want outside air. If you're sitting next to a Port Authority bus terminal in New York City, you probably don't. So there are strategies around it, but again, basic concept of flushing more outside air in a building does make sense. It's a benefit from ASHRAE's perspective.
Perfect. Thanks.
And Jack, one question on my part, and this is more just to get your opinion on something, because you were talking about when you're moving all the ductwork from the top and we're moving it to the underfloor. One thing that we get with mass timber buildings is it just frees up the ceiling to really expose the beautiful panels that mass timber buildings are really, that make them really desirous for a lot of people. What other kinds of design advantages do you think a UFAD design building would have, other than just clearing up the top space versus a traditional overhead system in a mass timber building? Is there anything else you can think of?
Well, I mean, the aesthetics for mass timber are enormous, right? But I think that when we look at what's the term, I'm learning about mass timber as we go, but you guys, I think, use the word biophilia. And the more we can maximize that sense of nature and that closeness to, something other than concrete and steel, that really matches up really well with what you just said. It's not just the aesthetic; it's also the whole experience in the space to really hide or eliminate and or hide a lot of the sheet metal and a lot of the non-biophilia kind of stuff that we're trying to really emphasize in a mass timber environment.
Cool. No, thanks for that, Jack. And yeah, Chris, just to add a word here at the end, I'm pretty excited about what UFAD can do in mass timber settings. We've seen a couple of projects already go up that we've been able to help out with, where we've been able to see how it looks really great. And, as I kind of think through what might help mass timber buildings improve on the story that they're trying to tell with energy efficiency and everything, it seems to me that UFAD kind of magnifies a lot of what mass timber is already trying to accomplish in terms of using less energy, trying to store carbon in their buildings. I don't know if there's anything else you want to add to that, Chris.
Nothing more than I think that the combination of UFAD and mass timber construction really complement each other. There's the energy efficiency story. Mass timber is already a green strategy, and we're just amplifying that. And to Jack's point, by eliminating a lot of the overhead distractions, we're exposing more of the natural wood and giving people more of what they're looking for. So hopefully we get a chance to do a few more projects, and we've got other modules that people can look at to learn more about the different ways we improve mass timber buildings.
No, certainly. And yeah, thank you, Jack and Chris, for coming to our conversation today. And thank you anybody who's watching the video. Like Chris mentioned, we will be having more of these to talk a little bit more about how our global integrated solutions and package can fit into mass timber building. So thanks everyone for attending. We hope you have fun at the conference. Have a nice day.
Thank you.
Thank you.